Well, thanks, folks, for having me. And for those who are going to see this on the recordings later, maybe just can follow me on Twitter and ask me any follow-up questions if you have them. We're going to talk about Knative and Cloud Run and what's the relationship between these two things. A little bit of context before I get started. I do have just a couple of slides. I think I have 20 slides, and then I'm going to jump into like a demo, and I think that's where the value is. I mean, the context is basically about why are we releasing yet another serverless product. You know, Google is known to have, or at least if you've been working with Google Cloud, you know we have quite substantial amounts of offering, App Engine, Cloud Functions, GKE. In a way, you could consider it as a serverless platform. But the thing with serverless is that it's a word that can mean a lot of things and nothing, depending on context. But the reality is that we've been doing this for a very long time, right? Google have been running Borg for more than 15 or 16 years now, which is the thing that inspired the creation of Kubernetes. But basically, Borg is our internal or container orchestration system, which allows us to run containers at scale. And that's where we run everything, including search and Gmail and all the stuff. But the reality is that serverless is more than just functions, right? Whenever people talk about serverless, the word itself have been introduced by AWS through the AWS Lambda service a few years back. And people, when they think about serverless, they think about compute, essentially, or functions. So it's a piece of code that gets executed by an event, whether that's like a messaging queue, sending a message in a messaging queue, or calling an HTTP endpoint or something like that. Serverless have properties. The properties for serverless can be different depending on who is interacting with the serverless platform. From an operating perspective, serverless means you don't have infrastructure to manage. It doesn't mean that there are no servers. There are certainly servers, but you don't have to manage them. It means also that you have some sort of built-in security, and then it certainly has to be a pay-as-you-go platform. If it's not pay-as-you-go, it shouldn't be called serverless. It should be called hosting, essentially. From a developer perspective, serverless is always a service-based service. So it's always some sort of API that you call to get something done. You should not be spending your time setting up servers and SSHing into them and patching them and stuff like that. It's event-driven, so that's something that we know. And then ideally, it should be open. That's kind of the goal of Cloud Run, at least. We have been running serverless across multiple areas for a very long time. On Google Cloud, some of the examples would be things like Spanner and Google Cloud Storage for serverless databases, BigQuery for analytics, serverless analytics, PubSub for serverless messaging, Google Cloud Build for serverless CI, and so on and so forth, right? So it's not just compute, it's a lot of things. And so a few years back, obviously containers have been introduced and people have been using them for a lot of things. But for some reason, a lot of the serverless platforms that existed up to today have always been built on top of some non-containerized proprietary information, or at least some proprietary technology that does not expose the containerization layer to the user. If you think, for example, about App Engine, setting aside the flexible option of it, I'm talking about the standard option, it is containers under the hood, but you don't see them as a user, you don't interact with them. You use a proprietary framework with a proprietary web server to write your code and deploy it. So you cannot bring whatever code you want. You cannot bring whatever runtime you want. You have the option of using 4 or 5 programming languages. So you're kind of limited in terms of what you can use. If you think about functions, for example, same thing. If you think about Lambda, same thing. Lambda is powered by some now open source technology, but it's not a containerized technology. It's a micro VM technology. So the advantage of containers is that they allow you to bring any library, any binary, any language you want, right? You can write code in whatever pretty much language you want. They do have granular version control. You can tag images, obviously. And there is an existing huge ecosystem of base images. You hardly have to start from scratch when you're building a container. You usually build it based on an existing container, right? So one of the advantages of containers is portability, is the fact that you can build a container in one place and take it and run it in another place. And when we talk about portability, people have been using Kubernetes to a large extent in the last 2-3 years, I would say, in production, because it offers that. It offers the possibility to run containers at scale and make them portable. You can make developers write code in containers in their Mac laptops, bring them into a Kubernetes cluster built onto a Linux system, and then they will just run transparently. They should not be any modifications between the build and the run of the containers. But the problem with Kubernetes, or one of the problems with Kubernetes, is it's not like a perfect platform. It is very complex. The bar to actually learn and master Kubernetes to be able to run it at scale is super, super high. You have to learn it. You have to learn how to debug it. You have to ideally use a managed version. If you are going to run it yourself on premise, it's even more complex because you have to run the control plane. You have to manage the control plane. Updating it is super complex. So it's really, really complex platform. It is portable. It is great. It is awesome for running at scale, but it's super complex. So what happened is a few companies got together, including Google and Amazon and a bunch of other companies, and they started thinking about how can we offer a framework that can allow people to write and deploy applications on Kubernetes, but without having to hassle with Kubernetes. Let's say, to put it in an easy way, the way I like to describe it is, how can we remove dependencies on YAML files? Because if you've done some Kubernetes, you know that you have to write a lot of YAML files, right? So, and that's what Knative is. So they created this framework, Knative, which is a framework to build serverless applications on top of Kubernetes. It has a really huge community today. It has hundreds and hundreds of people, a lot of companies involved. And there is this project called Tekton, I'm going to talk about it later, which is Kubernetes native CI/CD. Knative, open source building blocks for serverless and Kubernetes. That's basically the kind of the motto of the framework. It has a set of different APIs or primitives, we call them. So everything is built on Kubernetes. That's the base. Then you have the build primitives. That's basically Tekton. So the build primitives started as part of the Knative framework, but today they have been broken away into their own standalone project called Tekton. Then you have the two main ones. You have the serving and the events. So serving primitives or the serving APIs are the part of Knative that allows you to serve HTTP-based traffic. The events part is the part that allows you to write functions that will react to messages in a queue or an HTTP call or changes to some other system. So that's basically your functions versus your web application. So with the serving primitives, you can do things like web applications, REST API endpoints, gRPC endpoints, and all these sorts of things. The events part is what allows you to build. It's usually used to the larger extent in the data processing world, where you're able to stitch different systems together with events, where like one message is produced by one system, then a function is executed that will produce results that will trigger another system somewhere. And then Knative is certainly, it's an open source product. It's certainly consumable in its own raw format. You can take it, you can deploy it, you can run it on top of your existing Kubernetes cluster. But the goal of Knative was actually to enable multiple cloud providers or multiple vendors to offer developer-facing products. Because at the end of the day, what we want to do is we want to shield away the complexity of Kubernetes from the end developer. So ideally, you do not want to actually run Kubernetes and then run Knative, because you're just adding another layer of complexity, essentially. And like a valid use case where you could still do that would be if you have a large company with a large IT department, and then you have people who are only dedicated to run Kubernetes and run Knative, and then all the developers in the company are just consuming it through whatever portal their company built for them. So think about it as like private cloud type scenario. So at Google, we have this product called Google Cloud Run, which is the stateless containers on Google Cloud fully managed platform. So it is essentially the serving part of Knative fully managed. So there are two flavors of Cloud Run. You have the fully managed version, which is entirely serverless. You do not have to manage anything. You do not have to create clusters and manage them, and you only pay for what you use. You have this thing called Cloud Run for Antos. Antos is our hybrid cloud offering. I'm not going to go into details, but basically Cloud Run for Antos allows you to take a Google tested and built version of Knative and run it on either your existing GKE cluster or on on a GKE on-prem cluster, which is a product which is part of Antos. So in the Antos umbrella products, there is web products called GKE on-prem, which allows you to deploy Google Kubernetes engine on VMware on-premise. And then you can take Cloud Run, which is, again, a packaged version of Knative, and run it there. Why would you want to do that? One main difference between the fully managed Cloud Run, I think I have a slide about that. Yeah, we're going to get into that. One fully difference between the Cloud Run managed version and Cloud Run for Antos is that on the Cloud Run managed version, you cannot make your applications private. They are by default exposed to the internet. You can make them require authentication, but you cannot make them private. With the Cloud Run for Antos, you can actually deploy your application and make it accessible from the internal network and not expose it to the outside world. And why did we do this? Because again, somebody would wonder, like, why would I take Cloud Run for Antos and run it on GKE if I already have GKE? Well, simply if you want to keep a consistent environment across multiple places. So if you have a set of public services that you want to deploy, you can put them on the managed version. And then if you have a set of private services, you can put them on the Google Cloud Run for Antos. But the way you would build and deploy applications is the same. So the experience is consistent because it's just Knative under the hood, right? So the whole point of Knative is that it doesn't matter how it is, whether it's the managed version on the right side, which runs on Google Cloud infrastructure, or it's the Antos version on the left side, which either run on GKE on GCP or on GKE on-prem. So that's basically Kubernetes layer. The Knative API is the same, and then the way as a developer or as an operator, the way you interact with the service is the same. You use the same GUI, the same command line, the same YAML files to interact with the API. Now, I said earlier that we want people not to use YAML files, and then this might sound counterintuitive. It's not. So there is work being done to allow people to actually deploy Cloud Run applications using YAML if they want to enable a greater customization. You can think about it as the GUI and CLI is the easy way, or like the quick start guide. The YAML is the expert mode, if you want. But the whole point here is that you have an easy way to get started, which is through the GUI or through the CLI. While if you take, by analogy, Kubernetes, in the Kubernetes world, the only way you can get going is actually to do some YAML. You can do kubectl to get like the easy going way, but it doesn't have a lot of options. Once you will want to start customizing your service, you will have to go down the YAML path, right? So a couple of differences between the managed version and the Antos version. Managed version, you pay as you go. So basically we charge per minute for the container. So for each container that we spin up for you, we charge from the moment the container is ready to serve traffic until the moment it's killed, right? So you don't pay for the startup time, you don't pay for the going down time, but you pay for the serving time. So whenever your service is up, and it follows the per minute bill in Google Cloud, which means each container, we're going to see this later, each container has certain amount of memory, certain amount of CPU. You pay for the memory CPU for the minutes that the container have been up and running. In the Antos version, the Cloud Run is included in the Antos pricing. Machine types. You have up to 2 vCPUs in the managed version. You can do 1 or 2 vCPUs per container, and you can change the memory. In the Cloud Run for Antos, you can basically customize it the way you want because you're running on GKE, so you can put whatever request or limits in terms of resources you want. Autoscaling, Cloud Run managed version can scale up to 1,000 containers. We're going to talk about how scaling works in Cloud Run later. I'm going to focus on Cloud Run managed after this. This is just like kind of an easy way to look at the differences. So in terms of identities, as I said earlier, the managed version is publicly available, but you can enable authentication. The Cloud Run for Antos is deployed using Kubernetes services, which can be private. So you don't necessarily require authentication, although you can add it. Now, the networking is the most important piece. So in the Google Cloud Run, the Google Cloud Run managed version, you cannot access the VPC on GCP. So if you have, say, a database or like a Cloud SQL database or a memory store database, you cannot connect to the database using private IP because it is not part of the VPC, right? However, for the Google Cloud Run for Antos, you can do that because the service sits on top of a GKE cluster, which is on your VPC. So you can keep all your internal communication private. URLs is another differentiator. For the managed version, we will automatically generate an URL for you, and we will automatically set up SSL certificates for you. So you don't have to do this SSL certificate setup. On the Cloud Run for Antos, you have to do that yourself. The last one would be, well, we run the Google Cloud managed version on Google Cloud infrastructure, while the Antos one runs on Antos itself. The isolation is implemented using gvisor. Gvisor is a container isolation or container sandboxing technology, which is open source by Google. There is a link there. I'll let you read into it. But basically, we isolate each container into its own gvisor sandbox, so the container cannot escape, essentially. How do we use it? I'm going to talk about these details later, but basically, it's a single command. You build the container, you push it into GCR, Google Container Registry, and then you run one single command: cloud, run, deploy, the name of the service, which image, and that's it. You have a few options. We're going to walk through those later: the concurrency, the memory, the maximum number of CPU, the authentication, the identity, the environment variables, blah, blah, blah. I'm going to talk about that later. For each service, we generate an HTTPS endpoint. So we do the HTTPS piece, which basically means that there is actually a load balancer in front of your service, which will get the HTTPS request unencrypted, and then it will push HTTP traffic to your container. So your container does not have to implement HTTPS endpoints. In fact, you cannot today make your service HTTPS. It has to be HTTP. You get login and monitoring out of the box. So you have a bunch of metrics that get uploaded into Stackdriver, and then as long as your container is writing logs to std out or std or and everything that goes into /var/log, we just collect it and show it to you on the GUI. The auto-scaling piece. So whenever you deploy an application, we create a new revision. If you have used App Engine, you'll be probably familiar with this concept, but it essentially means that we do not delete the old revisions. So whenever you deploy a new application or you update the existing application, we deploy a new revision, and then we will migrate 100% of the code to new, but the old revision will remain there, and you can always roll back in case you introduce some sort of bugs. The actual number of instances that are running is impacted by what we call the concurrency and the maximum number of instances. So the concurrency is explained on the left. The concurrency is basically how many containers, how many concurrent requests a single container can manage. An example here, if you do concurrency 1, means 1 request per container. If you do 3, means three concurrent requests per container. Obviously, the recommendation is to always have a higher number of concurrency. You have to test your application to make sure it can handle those number of requests. But a higher number of concurrency means a fewer cold starts, because imagine concurrency is 1. Each request will have to start a new container. There is a certain amount of time that your container requires to start. It scales slightly faster, and it gives you a better utilization of your containers, because, again, you pay per minute per container. So concurrency 1 means essentially for each request you're going to be paying for a container. Before you want to know more, I'm going to do a demo. And let's get started with something really easy. Can you guys tell me if you can see my visual code?
See it just fine.
Perfect. So let me go ahead and start with a super easy one. And that would be my Cloud Run demo. All right, so what I have here is a simple Go application, which is Hello World, the quintessential demo app for pretty much everything we're doing. So inside this, we have a main function. We listen on /. And this is the only requirement to bring your container into Google Cloud Run. The requirement is simple. You have to make your service or your application listen on a port that we pass to you through the port variable. So whenever we start a container, we will inject an environment variable inside that container called port, capital, and you have to fetch it and make your server listen on that specific port. And we're going to later deploy an app that will allow us to inspect which environment variables exist inside the container, right? So yeah, so this is simply here. What we do is we take the port. So what I do here is I try to fetch it from the environment. If it's empty, I set the port to 8080. This is just to allow local development. So when I'm running locally, my port will listen. Well, sorry, my container will listen on 8080. When I'm running it on Google Cloud Run, it will listen on a random port. Then what I have here is I have the handler. Here I am fetching another environment variable called target. and I'm gonna talk about that later. If the target is empty, I'm setting target to world, and then I write hello, and then whatever the content of target is. And then I have a simple Docker file, which takes Docker, the builder 1.14, yalala, multi-stage build. I'm not going to go into details, but basically copy it into the app folder, download the dependencies, and then build the container, go build here, then start in another container using Alpine. I'm just copying the server from the app folder of the previous container where I built it, and then I'm executing the server. So let's go ahead and build this application, right? So first thing, I need to build it. There are many ways I could build it. I could do a Docker build and then push it to GCR, because remember, my container needs to be in Google Container Registry before I could actually push it to Google Cloud Run. I could do that. I could do a Docker build and then Docker tag and then Docker push. There is another way I could do it, which is easier. I could use something called Google Cloud Build. I'm not going to go into details, but Google Cloud Build is our managed CI. And I could actually submit a build which will be executed on a remote server, not on my computer. So the way you do that is by running gcloud builds, which invokes the Google Cloud Build API, submit, and then -t, and then you give it a tag. So gcr.io. So all the images on Google Cloud Registry that are always start with gcr.io / the GCP project's ID. In my case, it's called Abdel Fattah Lab. It could be called anything in your case. And then we will just give it a name. I'm just going to call it Hello World Cloud Run. Very long name. All right. So while this is happening, let's go ahead and see what that looks like on the GUI. So I'm going to go ahead and open the Cloud Build GUI, which is this one. And I can see that there is a build happening here. So this is the build that I just submitted. And when I click on it, I could basically see the output. This is just the output of Docker. This is essentially the output you get when you are running Docker build locally. But this is just being executed on a remote server. So what that gcloud command did is that it took all my code, it put it in a tar file, it uploaded it to a remote server, and then unzip it, and then run Docker build on it. So while that's happening, I'm going to give it a second. So again, my image will be called gcr.io/abdelfattahlab /hello-world.cloud-run. So I'm just going to copy that link or that image URL. And then I will invoke the run deploy command. So gcloud run deploy, I need to give it an image. And then what will happen is that gcloud will put me through a bunch of questions that I have to answer. So first, do I want actually to use the managed version, or I want to use the Cloud Run for Antos version? Obviously, I want to use the managed version. So I'm going to do one here. Then I have to give a name to my service. I'm going to call it Hello World Cloud Run. And then it tells me which region you want to deploy it. I want to put it in Europe North 1. That's in Finland, which is very close to where I am. And then here is the last thing. Do I want to allow unauthenticated invocations to my service? Unauthenticated invocations means essentially that anybody on the internet can reach my service. I'm going to hit yes, and then we will see what that means later. I have a last demo where I have two services. I have a backend and a front end, and the backend is only accessible from the front end, while the front end is accessible to the internet, which is typically what you do with the web applications. Good. So my application is built and deployed, and as you can see, I've done it in like 2 seconds. So I'm going to go here into the Google Cloud Run GUI, just refresh my page. I have my service, Cloud Run, Hello World Cloud Run. I can click on it. And then I will just first things first, check that it's working. So I'm just going to click on the URL, and I have my Hello World. So yeah, nothing extraordinary there. I go back here. I have a bunch of metrics, but obviously my service did not have any traffic, so my metrics are empty. Checking the revisions. I see here that I do have only one revision, right? Which is fine for now. We're going to see this later. I can see the logs of the service directly here. So that would be because my application is writing logs toward /stdout. So I can see here that I have reached the service from Chrome. This was the request I made earlier. I can check the details, which region, unauthenticated, who deployed this. I can check the YAML. This is where it gets interesting. So the YAML file actually is showing me that the service is used in the API, the Knative API, right? And that's because Knative is an extension to Kubernetes API. So the way actually you deploy applications in Knative, in the open source Knative, is that you either use Knative CLI, there is like a KN, which is a command line, or you can write YAML files. And when you write YAML files, they exactly look like Kubernetes YAML files. It's just that the API version is knative.dev, right? So let's go ahead and do probably a change somewhere in my code and redeploy the app one more time. So what I'm going to do is, and I'm going to do change hello Indianapolis. Please tell me I didn't torture the name of your city. Is that correct?
Nailed it.
All right, perfect. So I'm just going to go here and just rerun my application. Again, before I do that, I'm actually going to show you how can I make gcloud not ask me each time which version I want to. There are two ways. I could do something like this. I could actually rerun the application, the gcloud command, -- platform manage, -- region, Europe North 1, but that's annoying. Or I could just set them as permanent settings. So I can do gcloud config set run platform managed. So basically says, sorry, the other way around. It should be like that, and then manage. So basically it says, please set a key value, which is run platform managed. And then I will just run another one where I set my region to North 1. And now I'm just going to redeploy my app, and it just asked me for the service name. I could also avoid having to do that by putting the service name after the deploy before the image. So now I'm deploying my new revision. As I told you earlier, each time you push new code to the existing service, we don't actually deploy a new application service. We just create a new revision. And my revision have been created. So I'm just going to go here and then go into the revisions. And I'm going to refresh my app, my page. And I can see here that a new revision have been deployed. And then 100% of traffic have been routed to it. So if I click on the same exact link, sorry. You know what I did? I didn't rebuild the app. I have to rebuild it, obviously, because I redeployed these in the same container, which is not going to work. So I had to rebuild and then redeploy. My bad. But while this is happening, what I'm trying to show you here is this whole concept of revisions. So essentially, there will be now, I'm going to redeploy the application. So there will be a third revision deployed. 100% of traffic will go to that one. So when I click on it, I will see hello Indianapolis. But I can go back and revert back to a previous revision by clicking on manage traffic and then switching the traffic. I can do 50-50. And then every now and then I will get like a different response. Or I can do 100% to the older revision, 0% to the new revision. So this is simple kind of redeployment scenarios that you can use with Google Cloud Run. All right, that have been built. Now I'm just going to redeploy the app, and then I'm going to nervously refresh this page. And I can see that a new revision is coming up. So a question I got to one of the times I was doing a talk about Cloud Run. So when you deploy a new revision, what happens to the old revision and what happens to the existing connections? We do not drop the connections from the existing revision. So if you had customers that were connected to the old revision, we will not drop those TCP connections. We will just wait for them to time out. Google Cloud Run has a maximum 10 minutes timeout that your container have to respect anyway, right? So eventually, after 10 minutes, everybody will be migrated to the new revision.
Can I ask a quick question about splitting traffic?
Yeah.
So if you say, for the sake of argument, you have 2 versions and you split the traffic 50-50, if a specific user is directed to one of those revisions, will they tend to stay on that revision, or is it random with every new request?
So there will be a load balance. So there will be 50-50. We load balance based on requests, right?
Got it.
So the first time a user will make a connection, so a TCP connection, we will choose one of the revisions. It will be connected to that, and then all the traffic going through the same TCP stream will stick with the same revision.
But if they disconnect and then come back later, it will be randomly
to another one. Exactly.
Okay.
Yeah. Again, as I said, there is like a 10-minute timeout on the container, right? So your user will never be connected to the same revision more than 10 minutes if you have a 50-50 or 70-30 situation. Make sense?
Yep. But that means you couldn't use it for like A/B testing of a new feature rollout or something like that necessarily.
You could. Depends on how your application is built. If you don't have long processing in the front end and your requests are very fast, you could.
Okay.
Right.
Got it.
So here, as you can see now, my new revision is the app I just deployed. Now, if I want to just say revert back to this one, I can just go back here, click on manage traffic, or also click on here. And then I can say, well, I want to go back from the 403 to the 402, 100%, save. So that's going to update it. It's usually very fast. As you can see, I'm not updating the URL, right? The URL is always the same because it points to a Google Managed load balancer. And now I'm back to the previous revision, right? Okay, so super simple. Now let's do something. You remember that we talked earlier about the fact that you can also pass environment variables. I don't remember where you can see them here, but let's do exactly that. Let's go back to my code. As you can see here, you saw that my code expects an environment variable called targets. What I can do is I can actually redeploy the app and just pass set in vars. So that's a flag that passes a target, which would be Sweden, right? So I'm just setting this environment variable target to Sweden, in which case the target will be fetched from the environment. This test will not pass, so it will skip it, and then my target will be set to Sweden. So just redeploy my app real quick. And this is a great way to pass, to do things like oh yeah, I have to migrate traffic back to because I updated the third revision, right? So I have to just migrate traffic back to it. So this could be used for things like, no, what's happening? Oh no, sorry, a new revision is coming up. Of course, I'm dumb. Sorry, it's a little bit late. Save. I should have just waited because the new revision was deployed anyway. I did actually just migrate traffic for no reason. Yeah, there we go. So now it fetched the environment variable from the environment, which I passed through the. So this is a great way to do things like staging production. You can just pass a flag that says this is the stage, and it will be deployed to the staging, and this is whatever, and all sorts of crazy things. So let's go actually check which environment variables a container has when it's spun up on Cloud Run. By the way, you can actually stop me for questions if you want, or if there is a question in the chat, maybe Michael, you can just tell me what those are. So I'm gonna go here and I'm gonna look for my app that, yeah, here we go, inspect. So this is an app that somebody else built. It was not me. So what this app does is essentially same thing, fetch some port from the environment, otherwise starts on 8080. And what it does essentially is that it looks for os.environment, right? And then it will just print all of those. It will just print all the environment variables, and then it will also print all the headers, right? So let's go ahead and deploy this one. Again, I just have to build it. So builds submit gcr.io log inspect. So I'm just going to go ahead and build it real quick. I've already built it, so I assume that this will go fast, hopefully. Meanwhile, if you have questions, again, just let me know. No, I didn't want to close that. I wanted to close this one. This one as well. So I'm going to deploy this application. I'm going to load it, see which environment variables are there, and then I will also pass some random environment variable to it, and then just redeploy it, and you will see that whatever you pass through the command line, or you can also do it from the GUI, We will just make it available inside the environment variable. One thing also, I got a question on Twitter this week. Please do not use environment variables to pass secrets. That is a really bad idea. Don't use it for passwords and API keys and stuff like that. We do have a product specifically for that. It's called the Google Cloud Secret Manager, which is an API-driven, lightweight HashiCorp Vault, if you want. I'm going to go ahead and take the URL to this service and just redeploy it. gcloud run deploy -- image, and just deploy it like that. I don't want to do anything else to it. So I'm going to allow unauthenticated calls. As you can see, this question to answer, do I want to allow unauthentication calls, happens only once when I'm deploying the service for the first time, right? I can change it later by passing -- no allow unauthenticated, and then it will be updated. So going now here, I can see that my inspect app have been deployed. Let's go into click on it here and then click into the URL, and I'll just make it a little bit big. All right, so what do we have? In terms of environment variables, we pass the revision. So this is the this is the revision name. We just pass it to the service. We tell it what's its home. We tell it what's the working directory. That's app, because that's how the container have been built. There is the port. You have your SSL certificates. You have the path, and these are Knative specific environment variables. In terms of the HTTP headers, I believe that the most important one you will be interested in as a developer is the X forwarded for. So this is my IP, right? This is when I hit the service. It basically, the load balancer, what it does is that it receives the requests. It terminates the SSL connection at the load balancer level, and then it initiates a new connection, HTTP connection, back to your service. But because of that termination, we lose the client IP, so it's passed in the header as the X forwarded for, right? When we will do things like authentication, you will also have the token of the user into the header. So you can actually fetch the user token into your service if you're interested in doing that. So now I'm just going to redeploy this app with some random environment variable. So I'm just going to set something like env value or something like that. Real easy. Boom. So I'm going to talk next about the authentication piece, because that's kind of one of the most important aspects of Google Cloud Run, through a demo which I already deployed, but I walk you through the code. My service is deployed. Now if I refresh, I have my environment variable here value. So I can pretty much pass any sort of random set of key values. Now we've seen how do you deploy a service. We've seen how do you pass environment variables to the service. We've seen all these sort of interesting things. Now let's talk about the authentication versus non-authentication piece. I'm going to delete actually these two services. I don't need them anymore. So I deployed already before we started. I deployed an app. And what the app does is that it has a backend. In the backend, there is a SQLite database inside the container, which contains a catalog of products. And then each time you hit the backend API, it returns a set of random products, right? Then the front end is basically fetching those from the backend and then deploy them. The first interesting thing to see is that the backend is set to only allow authenticated calls. The front end is set to allow unauthenticated calls. So let's go ahead and look into details of these two things. So first thing first, I want to see how my front end looks like. So front end is super simple. It's just a set of products with its description and price. If I refresh, I will get a different set of products, right? Super easy. Now, let's talk a little bit about the backend. So first thing you will notice is that the URL is actually grayed out. And that's because the service only allows authenticated calls. If I copy it and go here and paste it, it will tell me forbidden. So that's a 403, right? I cannot access the backend. Now, let's go ahead and see how can we still make a call. First things first, let's see the permission part. You can see in the permission part that because this service is only allowing authenticated, it basically means only these accounts here are able to access it. One of these accounts is my account. Not this one, sorry, this one. So I'm going to go ahead and try to make an authenticated call to the service using my account. So again, copy the URL of the backend. I'm going to go to my terminal. and I'm going to show you how I can do that. I'm just going to simply pass an authorization bearer. So calling the curl command using a header, passing the authentication bearer token. And where do I get the token from? Where? Well, my gcloud command is configured with my abdel@abdel.cloud. Whenever you do that, you have an authentication, a JWT token, right? You can fetch this JWT token using this command, gcloud auth print identity token. And remember, from the permissions page, I am one of the users who is allowed to make authenticated calls to this service. So then I can simply run this command and then replace the token with the output of the gcloud auth print identity token. I'm not going to run that command, obviously, on a publicly recorded call, because I don't want my token to be stolen, but I'm just going to pass it into the command. And then the URL of the backend is this one, and then this backend answers on /random. So I have to add /random at the end. So if I execute that, I get a JSON request. This is a JSON answer with a bunch of random products, right? Cool. Now, the question it would be asking is, how does my front end, which is this one, authenticate to the backend, right? Well, very simple. Let's start first by talking about identities. Each time you create a service or you deploy a service, the service have an identity. So if you go to the IAM page of your GCP project, you will see that you have something like this. So you have a service account, which is called, this is your project number, right? So if you go here and go to home in GCP, this number here should correspond to the project number here. /compute at developer.gserviceaccount.com. We call this the default compute service account. And pretty much anything that is computing Google Cloud, whether that's Google virtual machines, Google Kubernetes engine clusters, Cloud Functions, and in this case, Google Cloud Run, if you do not specify which service account would be associated with the service, we will use this service account. This will be the default service account that will be attached to the service. So if I go here, for example, to my to my front-end service, if that's one that I'm interested in, and I look into the revisions, I can see here that the service account associated to this revision is the default compute service account, right? Good. Now, what does that mean? That means that the service is started using a default service account. That service account has also an identity, which is a token, a JWT token. And there is something in Google Cloud Run called the metadata server, which essentially is an internal endpoint that the Google Cloud Run function can reach out to fetch a bunch of information, including the token to authenticate. And I'm going to show you how that works. Before we do that, I want to show you that on my backend service, this compute engine is actually permitted to call the backend. So if the front end would authenticate as the compute engine service account, it would be able to call the backend, because the compute engine has an editor role on the GCP project, which means it has the role required to make calls to the service. Now, if you want to make it more, let's say, restrictive, what you would have to do is you would have to deploy using custom service accounts. So create a service account for each service and then assign a service account for each service. And then B, you will have to give it a role called Cloud Run Invoker. The Cloud Run Invoker is the role that allows a service account to invoke a function. In which case, to put it more in perspective, what I would have to do in my case is that I will have to create a service account for my backend, another service account for my front end, and then I will deploy my backend as authentication required, so not public. And then I will give my front-end service account the Cloud Run Invoker role on this backend service. Essentially, IAM stuff, right? So how does that mean? What does that mean in practice? So let's go ahead and look at the code of my application. So now the only challenge would be that my front end will have to somehow fetch the token, build a header or a JOT token, and then send it to the backend, right, for authentication. And I'm gonna do that using an existing application, which is the one I deployed already. This is my friend. There is my friend of mine called West V-Man. He is a Dutch person, and he's writing a book about Google Cloud Run. I'm reviewing his book, and this is his code. So let's look here into my, sorry, I'm just gonna close this one. I'm gonna close this one as well. I don't care about that. So let's look into the backend. So this is the front end itself, sorry. The front end has this Go library called client. Whenever new client gets invoked, it will call a function. One of the things it does is that it calls the, where is it? I'm trying to find it. Yeah, sorry. It calls this token function, yeah. And then token function calls the get token direct. So what does that get token direct does? First things first is that it will call if metadata running on GCE. So this metadata function here is implemented through a library called the metadata library. So this is a Google Cloud library for Go that allows you to interact with the metadata server, right? So I just call it and say, like, am I running on GCE? Am I running on a Google Compute Engine? Because otherwise, this means that you are running the container on your local computer for development, right? So what it does is that if that's true, it will fetch the token URL. So the token URL is at the instance/service accounts /default, because this is the default service account in my case. If your service account would be different, you will have to use a different, whatever the name of your service account is, identity and audience. So this path in the metadata server would return the audience token, right? And then it gets so this is the URL, and then it uses that to build basically the token and return it, right? So once the token is built, then I will be able to, we'll be able to use it for authentication. So this is the get token part. I mean, the token function does more than that. It gets actually the URL of the token. It also gets the claim. It gets the JOT token, and it gets a bunch of stuff. The expire date, for example. So it gets all the information required to build a JOT token. You know, the JOT token has multiple kind of fields or like header, fields that you have to fit in. So this token function is essentially going to return an OAuth2 token. The OAuth2, by the way, library in Go, one of its cool things is that it actually allows you to build a token, but it also monitors for the token until it expires. So you don't build a new token on each call. So this is how you build a token from the metadata server, as we talked about earlier. Now, the second thing that you might be asking is, how does my front end finds the backend? How does the front end? So the most straightforward way that we could do it is basically hard code the URL of the backend into the front end code. Because as you can see, one of the things with Google Cloud Run is that you have this randomly generated string here that gets attached to the URL. The URL is basically whatever you called your service dash a randomly assigned string .a.run.app. So luckily, the Google Cloud Run has an API that allows you to do service discovery. And we can see that in the run ago. Yeah. So we have this function here called get service URL. We give it the region and we give it the name of the service, and it will cache it for whatever reason. And then it will call this other function called get URL directs, which I believe is somewhere here. All right. Yeah, there we go. So, and this will just construct the URL based on the string. So it will, it has an API. Well, there is an API, the API path, which will take the name of the service, -run.googleapis.com /API/serving/namespaces. Inside the namespace, we inject the URL, the project ID, and inside the service, we inject the name of the service. So this API endpoint here is your service discovery API. It is essentially the name of the region, -run googleapis.com, namespaces, the project's ID, services, the name of the service. So it will call this API endpoint, and this API endpoint would return the service name, which if my status code is okay, I return essentially the response to status code. Wait. Yeah. So it returns this to whatever it calls it, right? Yep. And then this thing will return the service URL, right? And that's how you do service discovery. So that's how my front end finds my backend. And that was it, pretty much, I think. Actually, we can look at the code of the log of the, because this application does actually output quite a lot of logs. And we could see the bootstrap logs. I believe we'll be able to find the logs of the beginning, which would have actually the logs of the service discovery parts, but I'm not sure where they are. Haven't actually looked in detail into the logs of this thing. I think they should be there. But anyway, you get the point. The point is that okay, product not found. Yeah, so I had an error earlier, and then I redeployed the app somehow. Oh yeah, so, well, okay, it didn't have all details. It just says ID token requested, expires at whatever. So this is the get token direct URL thingy. Yeah, so this is the OAuth library, which is basically checking, getting the URL token whenever it actually expires. And yeah, so that's it, pretty much. That was actually my talk. I hope it was useful.